Hello everyone, myself Sagar Ramesh Kutte, working as Assistant Professor, Department of Physics, GMD College, Sinnar, Nasik. Now, last lecture we will discuss origin of line spectra and selection rule. Now, in this lecture we will discuss one electron spectra and two electron spectra. First will be the one electron spectra. This diagram indicate that the one electron spectra. Let us consider the optical excitation of alkali atom. In ground state, this atom contain set of completely filled subshell. Pulse signal additional electron in next subshell. In optical spectrum of an alkali atom, the excited state can be described completely by describing the signal optically active electron, and the core of filled subshell can be ionized. The total energy of atom in equal to that optical active electron. Let us consider atom of sodium have similar electron, its electronic configuration 1s2, 2s2, 2p6, 1s, 3s1. The core of 10 electron contribute nothing the angular movement of electron, and 11th free electron is possible for spectrum. These 3s electron when excited jump to higher energy state such as 3p, 4s, 3d, 4p, 5s, 5d, etc. Depending upon excitation energy, when the atom returns back to its lower energy state, radiation is emitted in the form of photon. These electron transition atom higher orbit to the lower orbit are responsible to different line observed in sodium spectrum. In sodium spectrum, some line consist of doublet, as well known that the first member of principal series is the sodium yellow line, which seen to consist two lines very close to each other and separated by 6 angstrom. These lines are due to transition from P state to lower S state. On the line in the P, D, F are doublet and are said to be fine structure. Since there is only one value of J, the ground state of sodium is called as singlet. From P state, L is equal to 1, that is S is equal to half. Multiplicity 2S plus 1 is equal to 2 into half plus 1 is equal to 2. J is equal to L plus S, comma L minus S, that is J is equal to 3 by 2 or half. Thus P state is doublet state. Similarly, D state is also doublet state, 2D 5 by 2, 2D 3 by 2. The energy level diagram shows line in different series and their transition is spectrum of sodium. The main series of transition are as follow. First, sharp series n square s half gives 3 square p 3 by 2 half doublet n is equal to 4, 5, 6 up to infinity. Second will be the principal series n square p 3 by 2 gives 3 square s half doublet n is equal to 3, 4, 5, 6 up to infinity. Third will be the diffuse series n square d 5 by 2 comma 3 by 2 gives 3 square p 3 by 2 half triplet. Fourth will be the fundamental series, gives n square f 7 by 2 comma 5 by 2 gives 3 square d 3 by 2 comma 3 by 2 triplet, n is equal to 4, 5, 6. Now this will be the one electron spectra. Now second will be the two electron spectra. Consider helium atom having atomic number 2, electronic configuration 1s2, that is n is equal to 1, L is equal to 0. There are two 1s electron in ground state of helium and coupling affects the properties and behavior of helium. The experimental work confirms the Pickering series arises ferromagnetic helium atom. The ionized helium gives rise series of spectral line separated by 1 bar s is equal to 4 r bar bracket 1 upon m square minus 1 upon n square. When electron transition is formed, m is equal to 5, 6, 7 up to infinity to n is equal to 4. The group of line is called as Pickering series. The line is laminar series lies ultraviolet region. These two series are given by the n is equal to 2 and m is equal to 1 and m is equal to 3, 4, 5, that is n is equal to 2, 4, 5 up to infinity. Now this will be the 2 electron spectra. Now in this lecture we will discuss 1 electron spectra and 2 electron spectra. Thank you so much.